Okay, we're going to talk about solving inequalities today, but before we get into solving, we're going to talk about the basics of inequalities first and what they mean and the symbolism that is associated with them. So we're going to use two different notations when we're talking about the solution to inequalities. The first notation is called set builder notation, and this is what you've seen before. You may not have called it that, but that's what you've been using in your middle school math classes. The second one that's new is called interval notation, so we'll get to that one in just a minute. So first let's talk about just knowing what these symbols mean. What I've noticed from teaching algebra is a lot of times you guys are really, really good at telling me which number is bigger, but sometimes you're not quite sure how to say that symbol. So make sure that you're comfortable with that before we get too far into inequalities. So that first symbol is a less than or equal to symbol. The next symbol is a greater than or equal to symbol. Down in the box below, the first symbol is a less than symbol, and the bottom one is a greater than symbol. The thing I always remind my students about is how similar an L and a less than look. A less than looks just like a tilted L. So if that helps you kind of remember which is which, then you can use that as a support. So now let's go on to interval notation. So what you're going to have are brackets or parentheses or a combination of both. And inside those brackets or parentheses or a combination, you're going to have two numbers. The smallest number that's associated with the solution and the largest number that's associated with the solution. And then the bracket means that the solution includes the number that's next to the bracket. So if this number right here, if the smallest number was a 5 and it had a bracket next to it, it would mean that the solution equals 5 as well as being larger than 5. And we'll do some examples of that in just a minute. Now let's go down to the parentheses. Again, it's intentionally grouped with the less than and greater than sign. So again, you're going to have parentheses or brackets or combination, and you're going to have the smallest number associated with the solution and the largest number associated with the solution. If you have a parenthesis, that means that the solution does not include the number associated or the number that's next to the parenthesis. So let's just say that right next to this parenthesis, there's 25. What that means is that 25 is not included in the solution, but 25 is the largest, like it's the top part of the solution. So it would be something that was all the numbers less than 25 but not equal to 25. And then finally, we're going to graph solutions to inequalities on a number line. And the thing that students usually miss here is whether the dot needs to be open or closed. So if you have a closed dot, what that means is that the number next to that dot is included in the solution. And if you have an open circle or an open dot, the number by the dot is not included in the solution. So again, that top line, all the symbols on that top row, the numbers associated with those symbols are included as a part of the solution to the inequality. But for the bottom row, all the numbers associated with those symbols are excluded, are not included with the solution. So let's do some examples. So for example 1, we're not going to solve yet. I'm just wanting to review how to graph inequalities with you. So I'm going to write what this statement means. This is saying that x can be any number, any number greater than 5. Okay, so think about what that means. Let's just say 5 is right here. If we zoomed way, way, way into that line, it's basically saying that x could be right here because maybe that number is 6.2 and 6.2 is greater than 5. Or x could equal exactly 6, or x could equal 8, or x could equal 7.5. But any number, so we could keep on drawing x's. And x can be any number to the right of 5. So what does that tell us? That helps us know which direction we're going to put our arrow. So let's put our arrow going to the right. Now the last thing we want to ask ourselves is 5 included in the solution? Well, notice the wording there. It says x is greater than 5, not x is greater than or equal to 5. That means we need an open dot on 5. And there you've graphed your solution. Keep in mind, inequalities almost always have an infinite number of solutions. Now, the last thing I want to do with you is let's actually write this solution in interval notation. What you're gonna do is you want to write the smallest number and the largest number associated with the solution. Well, we can see right here that 5 is the smallest number. So we're going to have a 5, and then we need another number that's going to show us the largest number. Well, here's the deal. This arrow right here tells us that that line keeps going on forever and ever and ever and ever and ever. So what number is at forever? It's the number infinity. So the two numbers that are a part of our interval are 5 and infinity. Now let's talk about whether 5 and infinity are included. Remember from the table above, if the number is included, you're going to have a bracket. If it's not included, you're going to have a parenthesis. So let's talk about 5. Because x is greater than 5, it's not greater than or equal to, 5 is not included. Therefore, you must have a parenthesis. Now, what about infinity? Here's the deal. Infinity is one of those numbers, it never ends. So it's like you can never reach it because it never ends. It keeps getting bigger and bigger and bigger and bigger. So anytime you ever use infinity in an interval, it has to have a parenthesis. So there we've got interval notation for the solution. This is set builder notation for the solution, and this is the graph of the solution. All right, let's do the second one. So some students don't like it when the variable is on the right-hand side. So I just want to make sure you guys know you can always switch it around. What I would suggest doing is maybe circling the bigger fish. So if you recognize A is the bigger fish there, when A goes to the left, then the fish's mouth has to open toward it, or Pac-Man's mouth has to still open toward it. So it's fine to switch the inequality around as long as you switch everything, including the inequality symbol. All right, but I'm going to go ahead and I'm going to model for you how you could graph this without having to switch it around. So if I rewrote this in words, it would be that 3 is less than or equal to whatever A is. Okay, so let's just say 3 is here. 3 is smaller than, it's less than A. So that means that A has to be on the side that's bigger than 3. So A could be there, or it could be here, or it could be here, or it could be here, it could be way over here. But all of those numbers that I've represented with a yellow dot are the different places, some of the different places where A could be. So that tells you where your arrow needs to point. So we need to point our arrow to the right. Now we want to ask ourselves, is 3 included? Look at your inequality symbol. Since it is a less than or equal to, that means that 3 is included in the solution, so we need a closed dot. And finally, let's do our interval notation. The smallest number in the interval is 3. Notice it keeps going on forever and ever and ever, so it's going to go to infinity. 3 is included in the solution, so we must use a bracket. Infinity is not included in the solution because it can't ever be, so we're going to use a parenthesis. All right, let's go on to the next one. So now we have r is less than negative 2/3. R is, so it's any number less than negative 2/3. Okay, so let's say that negative 2/3 is right here. So r is any number smaller than that. Well, where are the numbers smaller than that? It's going to be to the left of negative 2/3. That tells you which direction to draw your arrow. So our arrow needs to go to the left. Now, do we have an open dot or a closed dot? Because it's less than or equal to, and I need to fix that. Negative 2/3. Less than or equal to, we need a closed dot right there. Now, let's do interval notation. Now notice before, the numbers that we saw associated with our dots were the first numbers in our interval. However, in this example, the negative 2/3 is actually the biggest number in the solution. So what we're going to do is we're going to put negative 2/3 as the second number in the interval. Because it's included, we need a bracket. And then I want you to think about this. This is going to keep going on forever and ever and ever and ever and ever to not positive infinity, but to negative infinity. So our first number in the interval is negative infinity. And again, just like positive infinity, we can't ever equal it, so it has to be a parentheses. So there is interval notation. And finally, negative 2.3 is greater than whatever value c is. So negative 0.23 is greater than c. So let's say negative 0.23 is right here. Negative 2.3 is bigger than c. So think about it. Where are the numbers that are smaller than c, than 0.23? They're going to be over here. That's going to tell you which direction to draw your arrow. Now, is c included? Notice we have just a greater than sign. It's not a greater than or equal to, so therefore we need an open dot or an open circle. Now, for our interval, our lowest number is going to go on forever to negative infinity. We can't reach negative infinity, so it has to be a parenthesis. Then negative 2.23 is the largest number in our interval. It is not included as a part of the solution, so it also needs to be a parenthesis. Okay, here's a trick. I want to really caution you against tricks, but I want you to notice the shape of the inequality and the end of the arrow. So watch this. If your variable is on the left, the inequality symbol is going to match the arrowhead. Again, if your variable is on the left, your inequality symbol is going to match your arrowhead. Be careful. Here's where it falls apart because the variable is not on the left. So you would have to rewrite it. Once you've rewritten it, the inequality symbol matches the arrowhead. And again, here, if you were to rewrite this, you would have c is, remember the 0.23 is the bigger fish, or negative 0.23. So we've got to switch it around. And now the inequality symbol matches the arrowhead, if that will help you. Be really, really careful with that, though. I think it's way better to understand the concept of where are the numbers that are bigger than, where are the numbers that are smaller than, but you can check yourself that way. All right, we're going to move on to actually solving inequalities now. The procedure for solving inequalities is exactly like the procedure for solving equations, except for just a couple things. So first off, we've kind of already talked about but the solution with inequalities is almost always an infinite number of solutions. So usually with equations, you have one solution, although there are those exceptions. And the same thing is for inequalities. There's almost always an infinite number of solutions. However, sometimes you'll have exceptions to that. All right, the second thing is, and this is a big one, and it causes for lots of missed points on assessments and confusion. When you multiply or divide, highlight that. When you multiply or divide in the process of solving by a negative number, you have to reverse the inequality sign. All right, let's go on to example 5. So let's go through the whole process that we've gone through with equations. Can I simplify the expression on the left side? That's a no. Can I simplify the expression on the right side? That's also a no. Do I have variables on both sides of the equal sign? To that, I say yes. Now, I'm going to purposely make my variable term negative for this one. So I'm going to actually subtract 5x from both sides. I usually try to keep my variable terms positive, and I recommend that you do that. But for this one, and you'll see why in a minute, for this one I'm actually going to subtract my 5x so that then I have a negative 4x on the left side, bring down my minus 4, bring down my inequality sign. 5x minus 5x is 0, and then I'll bring down the 12. Next, we want to get our x value isolated, so we're going to add 4 to both sides. So then we'll have negative 4x is greater than or equal to 16. Now, to get x by itself, what's keeping it from being isolated is a negative 4. Negative 4 is multiplied, so we divide. Whatever we do to one side, we do to the other. And notice what I just did. I divided by a negative 4. At this point, you have to reverse your inequality sign. So now, negative 4 divided by negative 4 is 1, so I have x. But now I put is less than or equal to, and then 16 divided by negative 4 is negative 4. Okay, now let's graph it. So let's say negative 4 is right here. This is saying that x can be anything that is smaller than, less than, negative 4. So what are the numbers less than negative 4? It could be things like negative 5 and negative 5.5 and negative 8 and negative 7.2. So it's all of the numbers on this side of negative 4. Now, is negative 4 included? Because it is a less than or equal to, negative 4 is included, so my dot is closed. And finally, the solution in interval notation. It's going to go forever and ever and ever to the left and approach negative infinity. We've got to have a parenthesis there. And then the biggest number in the interval is negative 4. Because it's included, we have a bracket. All right, let's go on to example 6. So same process for equations. Can I simplify the expression on the left side of the inequality sign? To that, I can. I can distribute my 2 and get 2x plus 10, bring down the 3. I can continue combining like terms. Remember, we're not using inverse operations right here. We're doing the operation that the expression says to do. So we're going to say 2x, and then we'll combine the like terms of 10 and 3 to get 13. We'll bring down our inequality sign. Now, can I simplify the expression on the right side of the inequality? To that, I say yes again. So 4 times x is 4x. 4 times 7 is 28. And then I bring down my negative 2x. Again, we're combining like terms here. 4x minus 2x is 2x, and I'll bring down my 28. Now, I'm going to go ahead and deal with the variables on both sides of the equal sign. So I'm going to subtract 2x from both sides, and watch what happens. For this step, I end up canceling out all of my variables. So this should alert you to the fact that this is going to be either a situation where x can be any number, any real number, or x can't be anything. So let's see which it is. We're going to bring down what's left, and we're left with 13 is greater than 28. You want to ask yourself, is that true or is that false? That is false. Because that is a false statement, that means that this inequality has no solution. So no, you can't graph it on a number line because there's no solution. And for interval, we can't really say an interval. We can say that there's an empty set. That's sometimes what you'll hear. All right, let's go on to the next example. So we are going to simplify the expression on the left side of the equal sign. So we can distribute the 3. So we get 3x minus 1, bring down our 2x. We can continue simplifying because we have like terms that can be combined. No inverse operations here. We're just doing 3x plus 2x to get 5x. We'll bring down our minus 1. Now, we've got less than or equal to 6x plus 3. So now I'm going to subtract 5x from both sides. This is a time where it's really helpful to keep your variable terms positive. I know I broke that rule up here just so that you could see the flipping the inequality sign example, but it's really good if you just try to avoid negative variable terms. So let's bring down what we have left. 5x minus 5x is 0. We bring down our negative 1 is less than or equal to 6x minus 5x just gives us a 1x, and then we'll bring down our plus 3. Now we want to isolate our x value, so we're going to subtract 3 from both sides. And we find that -4 is less than or equal to x. You can switch it around, just make sure you also switch the inequality sign. So let's say -4 is right here. What this statement is saying is that -4 is smaller than the numbers you can plug in for x. That means that x has to be bigger than -4. Well, all the numbers that are bigger than -4 are on the right side of -4. So that tells us which direction to draw our arrow. Now is -4 included because it's a less than or equal to, or I guess here's a greater than or equal to. We have a closed dot. For interval notation, the smallest number in our interval is -4. The largest number in our interval, because it keeps going on forever and it goes in the positive direction, is positive infinity. -4 is included, so we need a bracket. Infinity cannot be included, so we need a parenthesis. And finally, these are the ones that are a little bit tricky sometimes in the way they look. They look like proportions, so you can cross multiply them. So let's look at what this would be when we cross multiply it. So for the left side, we'll have a -2 times 2x plus 1. For the right side, we're going to have a 3 times x minus 2. Notice what we just did right here. We multiplied by a -2. Anytime you multiply by a negative number, you must reverse the inequality sign. All right, so now let's continue our process. So I'm going to simplify the expression on the left side of the inequality sign. So I'm going to have -4x minus 2. I'll bring down the less than, then I can distribute the 3 on the right. So then I have 3x minus 6. All right, so now we have variables on both sides of the equal sign. So I'm going to get them together by adding or subtracting the entire term. Here, I'm going to keep things positive by adding 4x to both sides. It's not wrong if you decided to subtract 3x, but then make sure you don't forget to flip your inequality sign again. So let me bring this down. So at this point, we have -2 is less than 7x minus 6. Now what's keeping x from being isolated? This is when we start using inverse operations. We're going to add 6 because it's subtracted. Then we end up with 4 is less than 7x. Now because 7 is multiplied, we divide. Whatever we do to one side, we do to the other, and we're left with 4/7 is less than x. Or we can flip it around. X is greater than 4/7. Okay, so let's say 4/7 is right here. And I'll go ahead and do it from this perspective. X is bigger than 4/7. So think about where are the numbers on the number line that are bigger than 4/7. Here, 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 here. X can be in any of those positions, so that tells us which direction to draw our arrow. Now is X a part of, or excuse me, is 4/7 also a part of the solution? Because it's not a less than or equal to, greater than or equal to, it is not, so we need an open circle. For interval notation, the smallest number in our interval is 4/7. It is not included, so we need parentheses. The largest number in our interval, because it keeps going forever, largest number is infinity, and we can never reach infinity, so it's always a parenthesis.